Hi, everyone. Welcome to our second video for week 5, where we're continuing our discussion of hypothesis testing. And in this video, we're going to focus on the traditional method. So this is the method that statisticians use prior to calculators with statistics functions and accessible computer programs. So there are 5 steps to the traditional method. The first is to state that null and alternative hypotheses and identify the claim that we're being asked to test. So the word problem is going to give us one of these hypotheses with some keywords: less than, greater than, different than, equal to. And we're going to use those keywords to write both hypotheses and then label one of them as the claim, the thing we're being asked to test. Next, we're going to find the critical values and mark the critical regions on a labeled shaded graph of the distribution. And remember, we're using either a standard normal or a student t-distribution. So in both pictures, bell-shaped curve centered about 0. The critical value is related to that probability of making a type 1 error, that alpha value. That's also called the level of significance, and that should be given to you in the problem. It's related to how certain we want to be in our answer. Next, we're going to calculate a test value based on our sample data. This is where you need to show your work. If you're doing this calculation by hand, you should write the formula and the values you plugged in out. If you're doing this on a calculator, make sure you write out the name of the calculator function and the values you input into it. Next, we're going to compare that test value to the critical values from step 2 and make a decision about whether to reject or not reject the null hypothesis. Our very last step is to take that decision and summarize it using complete sentences. So in step 4, all we say is reject the null hypothesis or do not reject the null hypothesis. You're then going to take that information from step 4 and rewrite it in a complete sentence, tying that information back to the claim you were asked to test. More often than not, you're going to be pulling words directly from the problem to help you with phrasing. And later in either this video or another video, I do have a table with sentence frames to help you with step 5. So if you struggle with writing those sentences, there are sentence frames where you can just copy and then fill in bits and pieces from the word problem itself. So let's talk a little bit about these steps in general, and then we'll do some examples with each type of test we're going to do. So first, we're stating our null and alternative hypotheses using appropriate notation. So if it's a claim about a mean, you should use the symbol for population mean. And we know that that symbol is mu. So if it's a claim about a mean, you should be using the symbol mu. If it's a claim about a proportion, we know we use the symbol p. So you'll have statements about mu is equal to a number, and then mu is not equal to a number, or p is equal to something, and then p is less than something. So make sure that the symbol that you're using, that notation, matches the claim that you are testing. You should also, again, label one of those hypotheses as the claim that's being tested. So the wording in the problem should tell you whether it's the equality statement or the inequality statement that we're interested in verifying. Step 2, the critical values. So critical values depend on our level of significance, alpha, which is that probability of making a type 1 error. Again, this is connected to how certain we want to be in our answer. This is something that we determine as a researcher. In most problems, you're going to be given that alpha value. They'll either say use a level of significance of 5% or test the claim at alpha equals 0.01. If you are not given a value for alpha, assume 5%, alpha equals 0.05. That's kind of the default for students running hypothesis tests. If you are a researcher, particularly in the hard sciences, where you are making decisions about someone's life and welfare, you may use 0.005 instead of 0.05. But for the purposes of introductory stats, assume 0.05. That alpha, that probability of making an error, becomes the area in the tail or tails of our standard normal distribution or our t-distribution. And the critical values that we're finding in step 2 correspond to the boundaries of those shaded tail regions. And those will either be z-scores or t-scores, depending on whether it's standard normal or student t. The inequality that we use in the alternative hypothesis determines whether we have positive, negative, or 2 critical values. And oh my goodness, this is video number 2 where I've made a boo-boo. That should be greater than, and that should be less than. Shame on you, Andrew. So if the alternative is greater than, it's going to be a positive critical value because that alpha is going to be in the right tail. If the alternative uses a less than symbol, we're on the left tail of your picture. And so you're going to have a negative CV. We're down in that less than 0 side of the graph. If it's a not equal to in the alternative, you're going to have 2 critical values. They will be the same number. One will be positive, one will be negative, because we have 2 tails. Not equal to could be less than or greater. If you are doing a 2-tail test, cut that alpha value in half. Half the alpha goes in the lower tail, half the alpha value goes in the upper tail. So those 2-tail tests are going to look a lot like what we were doing for confidence intervals. We're going to have a non-shaded area in the middle and 2 shaded tails. You only cut it in half for the not equals. And if you're using a calculator, you don't have to remember that. The calculator will do it for you. So that note is only really important if you're doing this by hand. So here's a picture, and you should be drawing these when you do the traditional method. So you've got a right tail test. The alternative had a greater than symbol. So our alpha is that red region in the picture, and the critical value is the z-score or t-score that forms that boundary. For a left tail, that's a less than alternative hypothesis. And again, all of that alpha is in that red tail. And then for the 2-tail, that's when all our alternative is a not equal to. So half the alpha goes in the lower tail, half the alpha goes in the upper tail. We get 2 critical values that have the same number, but opposite sign. Step 3 is where we have to do some calculation. So the test value is a standard score based on our sample data. It's either a t-score or a z-score, depending on which type of test we're running. We can calculate these using a calculator or using a standard score formula, and we've seen those before. We're going to come back to both of those in a later video. This week, we are going to cover 6 different hypothesis tests, and each of those has its own calculator function and its own standard score formula. So again, those are going to come up in the individual videos for each test. But step 3 is where you're actually having to do a statistical calculation. Step 4 You plot that test value on the normal curve. If your test value falls in that shaded red reject region, you reject the null. If your test value falls in the non-shaded fail to reject region, you do not reject the null. And that is all step 4 is asking for. Step 5 is where we're going to take that information and write a conclusion. So you match your decision from step 4 with one of the following possible outcomes and use the sentence frame to help you write a conclusion. So you'll see this first column here is for when you rejected the null hypothesis. If the null was the claim we're testing, we would say there is enough evidence to reject the claim that, and then you rephrase that claim in terms of the wording of the question. If we rejected the null and the alternative is the claim, we would say there is enough evidence to support the claim. You will notice for both the reject boxes is enough evidence. When it's the null, we're rejecting. When it's the alternative, we are supporting. For the do not reject the null, both those boxes say is not enough evidence to. And then again, for the null being our claim, we're talking about rejecting it. For the alternative being our claim, we're talking about supporting it. Notice that you do not see the word prove anywhere in here. A single hypothesis test based on a single sample is not statistical proof of anything. It offers support for a claim, but we need repeatability over many, many samples before we can start to say that we are confident enough that that is a proof in statistical science. So I should not be seeing the words proven true in any of your conclusions. Suggest, support is okay, but prove is not. So wording here is very important. Okay, so I think there's 1 or 2 more videos with some intro stuff, and then we're going to jump into actually running these hypothesis tests. If you have any questions, let me know via email or drop by my office hours. Otherwise, I'll see you in the next video.